me doing it. Again, whenever I watch, sometimes it's painful, but I go in and watch my own lectures, and I notice that it's pretty much just me and the materials that I'm presenting. It's unlikely that your image will appear on that recorded video. But if you ask questions, it will appear on the recorded video. So speaking of recorded videos, even though I was kind of thinking that I wasn't going to record all these video meetings, I actually think I am going to record them all, and I will upload them to YouTube. And in the daily agenda that I show you today, I will tell you how to find those videos. Okay. So let me just go to slideshow. Oops. Gosh, you know what? Maybe not. I'm going to move this over here so that people can hopefully see it a little bit. Let's see if I can just zoom it up a little bit. Oops, that was way too much. Okay. So here is the agenda for today. And I want to just mention, in line with what I was just saying, down here at the about what 1, 2, 3 down here where it says lectures 1 and 2 and 3 posted on YouTube. Well, that's kind of a lie, because I haven't posted lecture 3 because that's today. But believe me, as soon as we're done with today's class, I will upload it to YouTube and you can go get it. Now, here's what I've discovered. If you want to find these lectures, here's the best way to find them. Go to YouTube and in the search line, put Stephen Mackey Bio 156. And you're going to see a bunch of lectures because I've posted a lot of lectures up there. But you're looking for the lectures that say, you know, that say dates like July 6th, July 1st, July 2nd, July 6th, okay? So, I mean, if you want to watch those old lectures, well, feel free. They're great in the middle of the night when you can't go to sleep. You can watch those. But the bottom line is that if you are interested in seeing the lecture that was just delivered, pretty much a recording of the entire class, which is totally zoomable for what it's worth. So you could decide, uh-oh, I missed the last 15 minutes and go just to the last 15 minutes as far as I know. Okay, one more time. So what I wanted to point out to you is Stephen Mackey Bio 156. Use that in the search line. And when I did that, it took me right to the videos that I'd posted. And the top 2 videos on that list were our summer school videos. All right. So those are available there. Should you want to watch them. They're long. I mean, they're going to be, you know, 3 hours or even more long than that. Okay. So pretty long things to watch. All right. So while we're looking at this agenda, and I don't know, could somebody out there just reassure me that you can actually see this agenda? Just chat it in and say, yes, you can see it, or
yeah, we can see it.
Oh, thank you. Thank you. I appreciate it because, again, I mean, it does say I'm presenting, that I'm the official presenter and that all that, but I have to admit to you that sometimes I'm unaware that I've been kicked off as presenter. It's probably something that I do. It's probably some little weird thing that I do that kicks me off as the presenter, and I don't even know it. And so I'm talking about. I'm sorry, I couldn't hear you.
Oh, I just said, yeah, we'll let you know if it happens for sure.
Thank you. Thank you. If it ever seems like I'm trying to refer to some kind of document and you don't see the document, then please let me know as quickly as possible so I don't feel so embarrassed about it. So anyway, here we are, Bio 156, Summer Session B, 2020, Day 3, July 6th. And you know, there's 20 days in summer session, and we are already on to day 3. I'm already behind, I'm sure. And so I'm going to try and get a little bit caught up today. Let me just go down this agenda real quickly and mention some things. The student information sheet, if you haven't gotten that back to me, please get it back to me. You can send it to me by email. I think you can drop it into an assignment section in D2L. I do have quite a few of them, but if you haven't submitted a student information sheet, please do so. The student information sheet is posted in two different places. I'm posting things in two different places now. I'm posting them on my PIMA, and I'm posting them on D2L. All right, so when it comes right down, apologize for that. This is my mouse for some reason. I don't know if I'm touching something wrong, whatever, but it likes to go backwards in the PowerPoint. So please, if you haven't completed that student information sheet, it is on my PIMA. So look, just for the record, everybody kind of keep this PowerPoint in mind, but I'm going to actually switch over here for a minute, and I'm going to go to, oh, I don't want to do that. I want to go to, there's where I wanted to go to. I wanted to go to home. So let's press home. I want to then go down to my courses. And it's loading. Then I'm going to scroll down all through all this stuff until I see my courses. Now you should have, you should have a page that looks just like this, right? And it's going to say Intro Biology, Allied Health, Summer 2020. So we click on that, and there's my introduction to my very basic introduction to the class. And then here on Drive, we're going to go right here to Drive. And on Drive, it opens it up. Here's a folder. We are in what I call my PIMA docs now. And here's a folder called Bio 156 Summer Session B. I'm going to open it up. And as you can see, it already has 10 documents in it. There, number one on the list, there's that student information sheet, which you could, it's a Word document, so you could download it. You could print it, you could fill it in, take a picture of it with your phone. There's the syllabus and schedule, there's the thought questions, there's the metric measuring PowerPoint, which I think is as up to date as it can be. I made corrections to it and I've updated it. Here's a document called metric prefixes. Here's that page called metric practice worksheet. Just to jump, look all the way over here. I posted it as I said I would. Here is the metric practice worksheet key. Now, I was encouraging people over the weekend to look at the metric practice worksheet to do those metric conversions. I will spend a few minutes talking about metric conversions again today. But there's the key to this metric practice sheet, and you can go and double check your work there, okay? Now, in this particular case, I wanted to be clear. I'm not collecting this metric practice worksheet. I put it out there so that you could work on it. I told you I would give you some time to work on it, and then I would post the key. And so there it is. The key is posted there. It's document number 08. Now, the documents that are listed up here are either Word documents, which can be downloaded, printed, modified, or they are PowerPoints. Like here's the What is Biology PowerPoint. Here's the, where is it up here? Metric measuring PowerPoint, which we're going to go to soon. And then I absolutely want to start today on this PowerPoint called Science and a Scientific Method. All right, so I just thought I would show you how to get to this if that was unclear. Honestly, I sort of think that getting to documents on my PIMA can be easier than getting them on D2L. But stuff is also simultaneously loaded on D2L too, so you have more than one way to get to this material. All right, I'm back here. Oh, of course. Okay, and where was that PowerPoint I had up here a minute ago? All right, so I jumped around a little bit. I apologize, but I wanted you to be able to see again that on my PIMA, in our Drive folder, there's the student information sheet. If you haven't filled it out, please fill it out and send me a copy for my records, okay? And then the syllabus and schedule is still up there, and it's still surrounded by question marks. because if anybody has questions about the syllabus, please feel free to email me those. Everybody, I hope, has memorized my email at this point in time. It's pretty easy to memorize. It's SMACKIE, SMACKIE at pima.edu. And so please email it to me. If you have questions about the syllabus, I would very much like to answer them. Then I've added some new thought questions for today. I'm still on O through W. And in fact, I would be happy to answer any questions on O through W for sure today. Still, that's metric system stuff. But then I've got B through G up here too, and B through G, of course, has to do with the scientific method. Okay, now this document, Thought Questions, is also posted on D2L and posted on my PIMA. And again, I want to be clear. These thought questions are there to help you focus your thinking and learning. As I said the other day, and I won't be too long-winded about it, I, like many college professors, used to think that students could read my mind. When I realized that they couldn't, I thought, hey, you know what? I need to start putting some of these questions swirling around in my mind on paper, because these are some of the essential questions about the class, and I'd like people to know what they are. I mean, I really don't want to be vague. I want to be as transparent as I possibly can. And there's no doubt whatsoever that some of these questions will be on the first quiz. So if you're looking at these questions, you're thinking about these questions, you will be able to answer the quiz questions better. The information that is used to answer these questions, well, look, I'm not saying you couldn't Google it. You probably could in some cases. Absolutely. A lot of the actual answers to these questions is likely to come at you in the form of PowerPoints, documents, etc. So I will, so I'll post these documents that are relevant in terms of thought questions, okay? I'm going to go back, to the metric measuring PowerPoint pretty soon. I'm going to, well, this one is a big one to me, the metric measuring at home lab and issues with it. So I'm going to come back to that in a minute, but I'm also going to start looking at the science and scientific method PowerPoint today. And then, just because everybody wants to know this, quiz 1. It'll be posted tomorrow morning. I will get it. I'm working on it right now. It'll be posted tomorrow morning. I will post it in 2 different places. I will post it on my PIMA, and I will post it on D2L. And it is an open note, open book quiz. I mean, I know that's hard to believe, but my quizzes tend to be, written quizzes. I might evolve, I suppose, or devolve into purely multiple choice questions that D2L can grade, but I actually, most of my quizzes are based on what I would call short answer questions. And short answer questions are questions that you can answer in a word or a phrase or maybe a minor calculation or a sentence or 2 at most. If you want to see an example of a short answer question, it's easy. Look at the thought question sheet, because most of the questions, if not all of the questions on the thought question sheet, are in the category of what I would call a short answer question. So when I've listed up here thought questions for today, and the last time too, because O through W was up there the last time, and maybe even remember it was A and O through W. A was the definition of biology, which you already know it. You've looked at that PowerPoint. You listened to me talk about it. Definition of biology is the scientific study of life and organisms. I mean, that's the definition of biology that we use at Pima College. Okay? And so there was that one other question. I mean, I can go back if I want to. There's day 1, and here we go. Thought questions A and O through W. Day 2, thought questions A and O through W. Day 3, I dropped the A because we're not going to talk about the definition of biology today, and I added in B through G, and I kept O through W because we're still working on the metric system. Okay, So I'm going to post that quiz in the morning. You will have, close to 48 hours to work on it. It's open note, open book, so feel free to consult whatever you want. The only thing I ask, and we are on an honor system here, is that I want to see your individual work. I don't really want people working with other people on this. This is you working. These quizzes are, going to make you think. They're going to make you, look at the notes and look at the PowerPoints and those kinds of things. But because of the nature of them, that you have quite a bit of time to work on them, and they are open note, open book, I'm going to be surprised if people don't do pretty well on them. So when the quiz is done, you can do one of two things. You can send me an email copy of it, right? You can it's a Word document. So you could fill in the answers to the quiz, save it, send it to me as an attachment, smacky@pima.edu. Or I'm also going to, of course, upload it to D2L, and that means that you will be able to drop it in the, assignment Dropbox, I hope. I wish I was more expert at D2L. I am learning it as fast as I can. Some people have emailed me with issues and problems. I've tried to solve those. I'm learning it as fast as I can. But there's more than one way to get that, there's more than one way to get it back to me. Okay. So it's due before class on Thursday. And you know what? As soon as class starts on Thursday, it's cut off. 48 hours you have to work on this quiz. You want to make sure you get it to me before 1 o'clock on Thursday. Otherwise, and I'll know when you've submitted it to me, because you're going to send it to me by D2L, or you're going to send it to me as an email. I'll know. And the reason is simple. I'm going to post a key to it before class, so that I'm going to post a key to it that we will look at the beginning of class. And honestly, once we've looked at the key to it, it kind of seems like it wouldn't be good to accept it after that point. And honestly, I'm just being gentle about it. I can't accept it after that point. Okay. So it's not like you don't have enough time to do it. I don't think. You've got plenty of time, plenty of resources. And does it mean that people are going to there'll probably be lots of 10 out of 10? Yeah, it probably does mean that. But that doesn't bother me. Under these current conditions, that would be fine. I'd be so happy to give away a bunch of good grades in Bio 156 under these conditions. Okay. All right. Any questions about this agenda? I'm happy to answer any questions that I can. Every day we will have an agenda like this. I'm obsessed with logistics, and so we will have some kind of agenda like this. Okay. So I want to go back to this line on the agenda, the metric measuring at home lab. And I'm happy to say I've seen some of these labs already. People have been sending them to me, and they look great. There's lots of little complexities in them, and the lab isn't actually due yet. I wanted to try and address as best I can under these conditions any issues people have been having with the lab. People have been emailing me about them, and that's great. I've been trying to address those. But one thing I want to tell you for sure is that good. When is the lab actually due? That's a really good question. I was wanting to not make the lab due until people had plenty of time to turn it in and had time to ask me questions about it. So let's make the decision. I will make the executive decision that that this lab is actually due tomorrow, Tuesday, by 5 o'clock. Okay, so let's just do that. Measuring to Tuesday, 5 o'clock. Now, many people have already sent it to me. So, and people seem to be doing well on it. One thing I want to mention, and I probably mentioned this the other day when I was crunching through it at the end. I apologize I had to do that, but is I don't want you to do any metric to English conversions but one, right? And we're going to go back and look at that one. You do not need to convert from centigrade to Fahrenheit. You do not need to convert from centimeters to inches. If you come into that lab, which is a generalized lab that I'm not the only person using this lab, we're testing this lab. This is the beta version of this lab. We're testing this lab. I personally think that it is largely a waste of time to make people convert between English units and metric units. There's one exception. So before anybody goes on the record and says, Steve, but before anybody, makes a note and says zero, there's not zero metric to English conversions. There's one exception, critically important exception. It has to do with the conversion between pounds and kilos, which we will go and review again today. Okay. So I'm going to actually go down to this PowerPoint and I'm going to put here, do 5P77, right? Do 5P77. And again, anything in it that asks you to do a metric to English conversion or Fahrenheit to centigrade conversion, you don't need to do that. The only conversions that you need to know how to do are the kilograms to pound conversions. And I'm going to go back and review that again because I ran out of time the last time. Okay. So I want to go back and I want to review that again. And I will. Okay. So that we have a chance to think about that and look at that a little bit. That is a very critical conversion that you probably are going to have to do almost daily in your clinical existence, right? The rest of these conversions, like, centimeters to inches or inches to centimeters or meters to miles, that is just busy work as far as I'm concerned. You'll never use it. I was really lucky to have a 6th grade science teacher who pounded the metric system into me. And so I've been pretty much dealing with the metric system my whole life and happy to. I'm happy to understand it. I'm happy to teach it to people. But in that time, the only metric to English conversion that I've ever had to do that was not just part of some busy work in a chemistry class I was taking was the kilograms to pounds conversion. And I've had to do that many, many times. So we're going to review that again today. Okay, we're going to review that today and kind of boom through some parts of the PowerPoint on the metric system again, and we're going to focus in on the one metric to English conversion that you really do need to worry about. Okay, and that is also included in the lab. Okay, it's included in the lab. So, all right. What the heck? Where did I put that? Oh, there it is. I put it in the wrong day. All right, so metric measuring lab at home. I'm going to put it here. Do 775P. Look, you know what? Here's the thing. If you can't get it all done by that time, turn in what you can get done. Right? Because I do give partial credit, and I'm happy to give partial credit on that kind of thing. So do the best you can. And honestly, I'm going to have to sort of evaluate the input that I get on that lab and the answers to questions on that lab, because as I said, this is like we're testing a kind of beta version of that lab. And that's going to make me be inclined to be pretty liberal with points as we test our way through it. So, and if you find issues with it, you're going to let me know that by email, or you're going to scream them at me right now. Okay, so Now I do want to go back for a second to this list that I had the other day here. Come on, computer, let me do it. The list. Did I lose the T here? Or? Yes, I did lose the T. There was a T up here before. No, there it is. Okay. So here's a list of things I'd like it if you could get. A ruler that has metric units on one side. Here's another ruler I got at the Dollar Tree. 3 for $1. This cool ruler. This cool ruler is cool because well, I like this one because it's clear plastic, which means I can actually see. So I don't know. I don't think this is me reverbing. Somebody's got their microphone on and I can hear them making a pizza. I don't know who it is. Sounded like they were making a pizza. I don't know. Anyway, metric ruler. And here's the thing. If you don't have a metric ruler yet, please get one. Okay? Some of these metric things we're going to come back to again and again. So as soon as you can get this equipment, you should get it. I'd like it if you could find a measuring cup. You probably already have one in your house that's labeled in metric units. That is milliliters on one side at least. Most kitchen cup measurers have ounces. That's evil English ounces, the imperial system on one side, and then they have metric units on the other. Okay, a 1 liter bottle. Well, you know, you can get any kind of 1 liter bottle, but look at this beautiful 1 liter bottle I got today. I got to talk about this bottle, or not, but I didn't get this today. I got it the other day, but I like this one because it's got kind of square dimensions, and that's going to be useful in helping me re-explain something in the metric system that I'd like to explain. Sorry, Diet Coke. I don't know how I could survive without it. Alka-Seltzer tablets. You really need about 3 tablets. I hate to ask you to go buy a box of Alka-Seltzer. Somebody last week mentioned that you could buy Alka-Seltzer packets individually at Whole Foods, I think it was. And if that's the case, that would be great. Then you just buy 2 packets for 50 cents a packet or whatever. I haven't seen Alka-Seltzer at the Dollar Tree, unfortunately. I have seen Alka-Seltzer at the Circle K, where they'll sell.
I actually picked up some. It was like a 4-pack of Alka-Seltzer at the Dollar Tree. It's like under the medication next to the antacid.
Thank you for saying that. I went to 2 different Dollar Trees looking for Alka-Seltzer just because I was hoping to say the same thing. So great. It would be great if you could get them at the Dollar Tree, and that would be less expensive. I mean, look, I don't want to make you buy things that are real expensive. If we were at Pima, you would pay a lab fee, and they would provide us with this stuff. But they don't charge a lab fee in these virtual classes, and that sort of allows me to feel less guilty when I ask you to go buy some things like that. But I've managed to get a lot of this. I mean, no joke. I got the cup measurement. I got the rulers. I did not get this expensive Fiji water at the Dollar Tree, but they probably do have 1 liter water bottles there. Then they definitely have plenty of candies, some soft candies. Now, they have to be soft because we need to be able to poke a toothpick into them. We are going to build molecules using these soft candies. And again, you know, I suppose I could have asked you to buy a molecular model kit on Amazon.com or someplace like that, but it would be expensive, and we won't use it so much that, anyway, I think what's great about the candies thing is that we can build molecules using those. We'll use toothpicks as covalent bonds. We can build some very basic molecules and look at them in a 3-dimensional way, which I think is essential. And then we actually will use gummy bears in a later lab. That's why I wrote here, gummy bears are essential, because we will do a later lab on osmosis and diffusion that has gummy bears as part of it. But, you know, I was able to get little gumdrops and little marshmallows and those kinds of things, easy things to build molecules with, okay? And then toothpicks, like I said, we need toothpicks for covalent bonds. And you may have a giant box of toothpicks at home already, and hope that that's the case. Again, please, when you go out to acquire these materials, unless you're just going to call Dollar Tree and ask them to deliver, I don't know if they do. Anyway, you please be very careful when you're out, and do social distance and wear masks and all kind of things. You know, I'm a scientist, and when the Center for Disease Control says go out and wear a mask, I don't ask myself much about it. I just go wear a mask, and I don't want to make it a political thing. It's like these are the highest mucky mucks, you know, as far as disease control goes. I don't think they want to make us wear a mask for any reason other than to prevent the spread of COVID-19. All right, so anyway, there's the list. I left it up there hopefully long enough that you could make some notes about it. Same with this. I'm not actually posting this. It's kind of a work in progress, but I wanted to leave it up there long enough so that you could copy it into your notes. All right? Okay, I might need this again later. I don't know. So here we go. I am now going to go straight to... Well, one thing I did have listed up here, just for the record, is there's those thought questions. And what I've got up here now is B through G, which this is science stuff, and O through W. And I don't know, some of this stuff down here in O through W is questions that could appear on the upcoming quiz. So just so you're aware of it. I did say that I would put at least one question from the syllabus on the quiz. And I did mention that that question would come from page 1 of the syllabus or from the top of page 3. So, you know, all that legalese and some of that other stuff that's there, don't worry about. You know, of course you should read that stuff, but page 1 and the top of page 3 contains, I think, the most essential information in the syllabus. And so please go ahead. That's where the answers to your questions are going to be found for the quiz. Okay. So I want to go to, where am I? Metric measuring PowerPoint. Okay. And go, yeah. Now, let me just walk through it this way for now. I'm going to go back to the very beginning, but you know what? I don't want to talk about ones that I've already talked about. These metric prefixes, there will be a question on the quiz about metric prefixes, no doubt about it, okay? Metric conversions, moving the decimal point around, that, you know, I've given you lots of opportunities to do that, to think about it. When you do the metric system lab, you can do it. When you do the metric conversion practice worksheet, you can do it. But I did have a couple of requests from people saying, Steve, could you just do another example of this? And I am happy to do it. So bear with me. If you are already an expert on this, then like I said, just bear with me, please. And what I'm going to do here, you know, I talked to some people about the whole mirror image thing, and they basically said to me, oh, no, Steve, that's no big deal. You can, mirror. I wanted to look at this. Somebody said you can actually program, whoops. Did I disappear there for a minute? Sorry. You can actually program it to not do mirror image stuff, but so far I've tried that and it hasn't really worked. So here's what I'm going to do. I'm going to stop presenting for a moment. I'm sure you can still see me. I'm going to grab a blank white board that I can use. And please, immediately, if this is backwards, then you're going to tell me. But here's the metric conversion. I'm going to move over here a little bit. And I'm just going to write the question this way. How many kilograms in 0.003 grams. Is it reading right?
Yes.
How many kilograms in 0.003 grams?
Yeah.
Good. Somebody said yes. Thank you. I appreciate it. All right. So remember what my 6th grade science teacher said. You always start with the only number you know. And the only number I actually have here is 0.003 grams. That's where I'm starting. Oh, it would be useful if up here I had the scale. Meters, liters, or grams. Okay, so over here, if we were on this side, we would have decimeters, centimeters, millimeters, asterisk, micrometers, etc. Right? On this side, we have DAM, decameters, hectometers, kilometers, asterisk, megameters. Now, again, I want to be clear. I could have written M, capital M, lowercase g for megagrams. Oh. I wrote MM because this scale just uses the meters in this case. That's all. This could have been capital M, lowercase m for megameters. It could have been capital M, capital L for megaliters, or it could be capital M, lowercase g for grams. Every one of these, I mean, these are the central units. And I can use the central units in any one of these. These prefixes, deci, centi, milli, micro, deca, hecto, kilo, mega, they can be applied, attached to any of these units, okay? But why did I use capital M, lowercase m? I guess just because the M was on the top here. But what we really want to know is, look, we know grams, right? But we want kilograms. So we know grams and we want kilograms. So here's how many grams we have, 0.003. Now look, I'm going to tell you, there's many people, myself included, who the minute you start to see little numbers like this, 0.003, you think, oh my gosh, how am I going to do that math? That math is just crazy. How am I going to do that math? But you know what? There's no math here. It's all moving the decimal place. So in order to go from grams to kilograms, I have to hop the decimal place 1, 2, 3 spaces this way to the left. Here's the decimal point. I'm going to have to hop the decimal point 1, 2, 3 spaces to the left. I'm going to write it there. Gotta write it there. I'm going to put a 0 in front of it because you gotta have a 0 in front of it. You can't, it's not technically correct to write 0.003. No, it's not technically correct. Because what is that? Is it a decimal place, or is it a period, or is it just a dot? The only way to know that it's a decimal place is by putting the 0 in front of it. Now you know, oh, it's absolutely a decimal place. 0.003. So what do I do with these blank spaces? They're powers of 10, so I fill them in with zeros. And there's the answer at the end, 0.00003 kilograms in that many grams. All right, so you're moving from where the decimal place is, 1, 2, 3 spaces to the left, right? Now, you can't just let that decimal place hang out in space. That's what that's about. So, bottom line is that it's just about moving the decimal place. I mean, if you had a question like, how many microliters in 27.3 hectoliters. Well, microliters way over here. Hectoliters here. All right. But here's the only thing we know. We know 27.3 hectoliters. So that's the number we're going to start with. 27.3 hecto. But what do we want? We want micro. So to go from hecto to micro, we're going to have to hop the decimal place. 1, 2, 3, 4, 5, 6, 7, 8. Those asterisks, they're not like little artistic flourishes I put there. They are decimal holding places. If this is 1,000th of something, then this is 1/10,000th, 100,000th, 1,000,000th. Okay, so I didn't count. I've got to move the decimal place 1, 2, 3, 4, 5, 6, 7, 8 spaces in what direction? To the right or to the left? Well, I started here. I'm going this direction, so it's to the right. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to put the decimal place there. I won't need it in the end, but I'm going to put it there anyway. And then what about all these little dips? Well, they represent hours of 10. I don't know what that one was. Weird. So there's the final answer. 2, 7, 3, 0, 0, 0, 0, 0, 0, 0. So 1,000, million, billion. There are 2,730,000,000 microliters in 27.3 hectoliters. That doesn't surprise me. Hectoliters is pretty big, right? 100 liters. And microliters are really tiny. That's 1,000,000th of a liter. So one more example, not in a mirror image, I hope. And that's the kind of conversions that you do when you do those kind of metric conversions. Now, I might ask you a question that's more like a word question, all right? A little bit more like a word question. And let me give you a perfect example. All right, here is a perfect example. The thought question, let's look at this thought question down here. R, I read somewhere that Albert Einstein loved ice cream. Uh-oh, I'm not presenting. Am I? Tried to show a document and I wasn't presenting. At least I remember it. That's a good thing. Document was thought questions 1. And there it is. I read somewhere that Albert Einstein loved ice cream. Would he rather have 1 kilogram of Rocky Road or 10,000 milligrams? Well, would you rather have 1 kilogram or 10,000 milligrams? And then here's the key. It says express both in grams. So this is actually asking you to convert kilograms to grams and milligrams to grams. And then you can compare and go, okay, 1 kilogram is 1,000 grams of ice cream, and 10,000 milligrams is 10 grams of ice cream. Would you rather have 1,000 grams, which is a pretty sizable amount of ice cream, or would you rather have 10 grams? So by converting, expressing both in grams, I'm really saying convert both to grams, and it's kind of a word question, and I don't really know if Albert Einstein loved ice cream. I think I read that somewhere. I do remember he invented the graduated cylinder, but I couldn't figure out a metric conversion question about that. Okay, okay. Back to here. So again, this guy does a halfway decent job. Believe me, I've looked at a lot of videos, and there's not many that I really like. This guy does a halfway decent job of illustrating that. Some of the stuff he does at the beginning, it's about a 10-minute long video, is not necessarily worth watching. Wouldn't kill you to watch it, but that's why I put down here, you can start at 4:45 just for the conversion part. Okay. Am I presenting? I hope I am presenting. I am. Okay, good. Hopefully somebody would holler at me and say, Steve, you're not presenting. So I'm just going to remind you that on the quiz, there will definitely be questions about metric prefixes. These metric conversions, these should be pretty easy to do. How many deciliters and 23 liters? And of course, you noticed here I put the scale, and there was a mistake that had appeared in it. I do not know how, but I corrected it. Then, these are just examples of the kinds of questions that I could ask you, right? And so you can look at these and so, okay, how many liters in a kiloliter? Well, that's a giveaway, right? Kilo means 1,000. So if you've got 1 kiloliter, that's 1,000 liters. Okay. We went through this the other day, and you could, of course, take a look at it if you'd like. This PowerPoint's posted. There's the metric conversion PowerPoint, this practice sheet right there. Just a screenshot I took of it. You have it available. A joke. Essential metric factoids. Okay, this is where I kind of wanted to be again. And the reason was, whoops, well, I wanted to be there, and the computer decided it didn't want me to be there. Okay, so figure out how to move this. Move this over. Because I'd like to demonstrate something. Remember this essential metric factoids I talked about the other day? I was talking a little bit about the history of the metric system and how they sat down in 1790 and they tried to create these standard central units, and they wanted to relate them together to the best of their ability. So, they started out with a meter, and I'm ignoring the English system down here where it's got inches and things, and I am focusing here on the metric units here. So the first thing they created was the meter, which was a unit of length, right, which was approximately 1/10 millionth of the Earth quadrant passing through Paris, meaning about 1/4 of the Earth's circumference. That's the distance from the North Pole to the equator, passing through Paris, France, right, because it was in Paris. They thought it was about 1/10 millionth, and it was not dramatically off, but it wasn't exactly 1/10 millionth. So they started with meter, and then they wanted to figure out how to somehow relate that to volume. And that's one of the reasons why I love this Fuji bottle. And the reason I like it, because it's kind of square. It's a little bit hard to do measurements on, a round bottle. But here's what I really think they did back then. They took something that was like a bottle of wine, and they took out their meter stick, and they started measuring the bottle of wine and trying to get an idea of the physical size of the bottle of wine. They weren't interested not only what was inside the bottle, but also how much space that took up so that they could create a volume. So on this particular bottle, very expensive water, $3 for this bottle at the Circle K. Not available at the Dollar Tree as far as I know. And I liked it because it's squarish, because what I can then do is I can take this ruler and I'm going to measure it in centimeters. So I'm going to measure its, in order to calculate the volume of something like this, you have to have the length times the width times the height, okay? So you need those 3 dimensions. There are things like this in the lab, as you know. So I'm going to estimate, just looking at this, I'm going to estimate that its length is about 7.2 centimeters, 7.2 centimeters in length, 7.2 centimeters wide. Okay, so 7.2 times 7.2. And then as far as its length goes, let's say about 19 centimeters. Now, maybe you can do this all in your head, but I can't. So 7.2 times 7.2 times 19 equals, oh my gosh. Well, pretty close. 985 cubic centimeters. Now, you know, I wasn't able to really measure this top part here. That was difficult. But the point is that this is pretty darn close to 1,000 cubic centimeters. 1,000 cubic centimeters, or like it says here on the PowerPoint, that is extremely close to 1 cubic decimeter. Same thing. A cubic decimeter would be a cube that was this wide, a decimeter. I always remember a decimeter is about as wide as the palm of my hand, right? And it's a decimeter wide, a decimeter deep, and a decimeter high. That would be 1 cubic decimeter. It'd be a cube about so big, right? I mean, manageable. If we were in class, I would pass one around as show and tell, a cubic decimeter. But also, as you saw when I did these measurements using this ruler, that it's really very close to 1,000 cubic centimeters, which is the same thing. 1,000 cubic centimeters is the same as 1 decimeter, 1 cubic decimeter. So these factoids here were designed to sort of create an actual physical volume. Then it was based originally, like I said, on what seemed to be the volume of a standard bottle of wine. They call that a liter. And they were able to relate that to a physical volume in, well, units of a meter. Of course, they then also decided that the weight of a liter is 1 kilogram if it's liquid water. That's a big if. You can't use anything else. Believe me, 1 liter of air, the air that's inside this 1 liter, it does not weigh 1 kilogram. In fact, I don't have a balance that could even measure it. It's so low. If it was gold, it would weigh, it would be difficult to lift. It would be so heavy. So it's only liquid water. And believe me, I will be picky about that if I ask you a question about it, okay? Only liquid water. Now, for what it's worth, if you divide this by 1,000, you get 1 cubic centimeter. Divide this by 1,000, you get 1 milliliter. If you divide a kilogram by 1,000, you get 1 gram. So this section here, it says 1 cubic centimeter. That's, you know, a cube that's about as big as a sugar cube. Is the exact same, not about, sorry, I made a mistake there. It's the exact same volume as 1 milliliter, and it will weigh 1 gram if it is liquid water. So that kind of does bring up a thought question for me, and the thought question is, what is the approximate weight of a 2-liter bottle of Diet Coke? You've probably seen that thought question and pondered it, and I hope you didn't go out and buy a 2-liter bottle of Diet Coke and try and weigh it, because you don't need to. Number one, I did say approximate, so I'm going to ignore the plastic bottle. But if it's a 2-liter bottle, then it's 2,000 milliliters. That's a metric conversion. And if it is 2,000 milliliters of Diet Coke, which is 99% water, I'm going to assume it's about the same weight as water. You know, what's funny is you can't use regular Coke, because regular Coke has so much sugar in it, it's heavier, much heavier than Diet Coke. But if it's Diet Coke, it's basically just water. And if it's 2,000 milliliters of water, well, look at the deal. 1 milliliter of liquid water will weigh exactly 1 gram by definition. And that means that you can say 2,000 milliliters of Diet Coke, pretty much the same as water, 2,000 milliliters at 1 gram per mil means it's going to weigh about 2,000 grams. And that's absolutely true. I think I said this the other day. One of these Diet Coke cans has 355 mils of Diet Coke in it. And despite the fact that, well, actually, Diet Coke's cheaper than that Fiji water. But bottom line is 355 mils. What would the soda inside this can weigh? Well, it's going to weigh darn close to 355 grams. Right? 355 mils at 1 gram per mil for liquid water. And so there you go, 355 times 1 gram. Now, will ice work for this? No. Ice won't work for this. Ice actually weighs less than liquid water. There's lots of reasons lots of experiences you might have that will show you that. But the bottom line is, if you put ice in a drink, that's basically a watery based drink, the ice is going to float because the ice weighs less. So you can't use ice, and certainly you couldn't use steam because that's a gas, and gases tend to not weigh anything anywhere near as much as solids or liquids. So it's got to be liquid water. Flavored liquid water, like Diet Coke. Okay? And this was just me showing you those conversions. Down to measurements, we went through most of this the other day. You're going to demonstrate that you know how to do that stuff for me. And, you know, by doing that lab. You know, when I saw this the other day, you know, I mean, of course, you put together PowerPoints and you think about them. I saw this the other day, and ever since I saw it, I've thought, my gosh, I got to get rid of this graduated cylinder right here. Because it's a nice picture. I like the yellow water and all that, but I don't like the graduated cylinder because they're looking at the side of a graduated cylinder. It's sort of counterintuitive here because it's not going up in the scale like 30, 35, 40, 60, 70, 6, 7, 8, 10, 11, 12. No, this one's actually reading a side of the graduated cylinder. It doesn't show you how much liquid there is in it. It shows you how much liquid you're pouring out. And some graduated cylinders are like that. So I need to get rid of that graphic. I apologize if that confused anybody. Okay, volume of fluid here. We did this the other day, and I'm sure you've had an opportunity to practice looking at that stuff too. Okay, so now centigrade and Celsius. I want to tell you this again. Don't do any conversions between Fahrenheit and Celsius. It is unnecessary. Most people know some things about the Fahrenheit system. I mean, they know, for example, that water freezes at 32 degrees. They know that that a room is probably about 70 degrees. They know human body temperature is 98.6 degrees, and they know that the boiling point of water in Fahrenheit is 212 degrees. Okay? Most people know that because they've used the Fahrenheit scale before. But you know what? As far as I'm concerned, we just forget the Fahrenheit scale. In the metric system, we tend to use the centigrade scale. And I underlined centi here because centi sounds like a metric prefix, which it is. It means 1/100th. These factoids here are the most important factoids, right? These factoids are what you need to know. That in the centigrade temperature scale, 0 degrees is the freezing point of water. 100 degrees is the boiling point of water. Human body temperature is 37 degrees, and the approximate room temperature is 22 degrees. Now, if you have a little metric conversion or a little conversion factor stuck in your head about this, well, then that's fine. I mean, 22 degrees times 1.8 is, oh my gosh, where's my calculator? 20, turn it on, Steve. 22 times 1.8 equals plus 32 equals 71.6 degrees. So it's low 70s, right? The bottom line is, though, I don't want you to have to do those conversions. You won't have to do those conversions. If you're working in a lab or in a clinical setting, you'll have a thermometer that's a centigrade thermometer, and you won't have to convert. So I don't need you to convert. Look, if you take a chemistry class, which some people will end up taking a chemistry class, if you take a chemistry class, then believe me, you'll have to convert from centigrade and Fahrenheit to Kelvin and all that kind of stuff, but not here in biology. We use a centigrade thermometer, okay? And so when it comes time to measuring it, you would use a centigrade thermometer. Now, digital balances. I have to mention them, even though you don't have a digital balance, and we haven't even been able to find like a tutorial about digital balances because they're so easy to use, right? You just turn on the balance, make sure it's set to grams. The thing about these balances is they come out of balance pretty easily. The ones that are in my classroom, you breathe on them, they come out of balance. So what you have to do is you have to basically reset the balance every time to make sure it's recalibrated to 0. And honestly, for most of these balances, here's an actual balance that I have, which I know is going to be backwards. I mean, this is what you're supposed to use for food. But most of these balances, you turn it on just by pushing the button, and then maybe this balance is crazy. Well, maybe it, see right now it's because I'm holding it up, it's acting crazy. But when I want to tear it, all I do is I had to hold this button down to turn the balance on. In order to tear it, and this isn't going to really work here, but I just click this button once, and it tries to reset it to 0. The fact that it's, being held in space is not really going to be very helpful here. I don't know. It might be able to tilt it down like this. And it's going to be backwards anyway. What am I saying? Okay. Bottom line is, I have to mention this because you will see digital balances in your future. And the main thing is that when you use a digital balance, you have to tear it. And that word T-A-R-E, which happens to be still listed in the thought questions because it's a meaningful word, it means to zero out the balance. And usually there's just a button, you just touch it, and it zeroes out the balance. Okay. All right, now, here we are at the page that says the only metric to English conversion you need to know, and that is the conversion between pounds and kilograms, okay? But you know what? I need to get up and stretch. It's been an hour and 15 minutes. So I'm wondering if we can just take a 10-minute break, run to the restroom, refill your coffee cup, whatever. I don't know if anybody is in the mood to take a break, but let's see. Is everybody in the mood to take a break? Yeah, it sounds to me like people want to take a break. Okay, so we're taking a 10-minute break.
Backyards everywhere, the best place to be this holiday. We're starting from the ground up. Get 5 bags of premium mulch for $10. And for a finishing touch, get select annuals hanging baskets, 2 for $10. This year, we're home for the 4th. Visit Lowe's and make it the best it can be. Valid through 7/8 in-store only. While supplies last, selection varies by location. U.S. only, excluding Alaska and Hawaii.
Mobile phone, got the big flush? Get fresh tech in a flash. Do-it-yourself diaper not doing the trick? Get diapers only the double. Last-minute surprise for little Susie's 6th. Get gifts, groceries, and more pronto with new Walmart Express delivery. Our door to yours in 2 hours or less. Same low prices as in-store, 0 markups.
Nice.
Nice and fast. So why wait? Try Walmart Express delivery. Like now. Restrictions and fees apply. Your beach, your patio, your summer, your music. AccuRadio. Music lovers, music lovers.
All right, here I am. You know, if you're going to do virtual teaching, you got to have one of these. This is one of the, I think, an essential element of virtual teaching, because you can use it to give yourself some good feedback, like you can do this. If you tell a bad biology joke and nobody's laughing, you have that. Or if you deliberately tell a bad joke, or even this. I like getting a round of applause every once in a while. So I don't normally get it in my life, but thank you. I've got this machine, and that machine is extremely useful under those cases. Anyway, you know where I got, you know what, I think I got this at the Dollar Tree. I should buy stock in the Dollar Tree. That was switching to all virtual. I think I'm going to be using the Dollar Tree more and more.
What do you call that thing?
Where? I got it. I think I got it at, as I said, I think I got it at the Dollar Tree.
What's it called? She's asking.
It's called a sound. It's just called a sound machine. I've actually got, I've got more than one. I've got this one. This one is really good if you are on a phone call and you want to get off of it because you just don't know, you know, you're like, oh, how can I get off this phone call? Because you can do this kind of thing. You go, excuse me, sorry, something's going on outside.
That's cool. Yeah.
And then, you know, you immediately go, I'm sorry, I gotta hang up now. Something bad is happening outside. And so that one's pretty useful for that kind of stuff. But the other sound machine that, you know, gives you a little drum roll or whatever. Oh, I mean, it'll fart. You know, it has every sound that you might want, you know, but, or lots of sounds. Breaking glass. Oh, sorry, I got it wrong. That can help you get off the phone call too. You know, oh my gosh. Anyway, I'm telling you, if you're going to do this, you might as well. You should have one of those things again. So while I mean, I know I've done this before, and I can't resist it. Is this cat here, my cat Mouser. He's right in here bugging me again now. This is that famous cat Mouser, the 10-kilo cat. He weighs more than 10 kilos now. 10 kilos would be, of course, 22 pounds. And I noticed he just had one of those line cuts for the summer. So most of his hair is gone, so he doesn't look that fluffy, actually.
He's
as heavy.
No. Sorry.
As heavy as my daughter, actually.
I'm sorry, I didn't hear what you said.
As heavy as my daughter.
Oh.
Yeah.
Well, he just, you know, he pushed the door open and came in the studio, but okay, Mouse, I can't talk right. I can't pet right now. I'm in class. My daughter brings her cats to classes. She teaches in the vet tech program, and she brings her cats to classes. So anyway, I want to go back for a minute because I just want to reiterate this again. This is the only metric to English conversion that you actually need to know. And you will use this in your daily life. There's no doubt about it, because it's very common. Well, let me put it this way. When they list drug dosages, they always list them in kilograms. But most of the time, when people get their weight taken, you go into the doctor's office, you take your weight, they list it in pounds. You go in the doctor's office, you go in the vet's office, they list the weight of your cat or your dog, it's in pounds. That the balance just automatically reads out in pounds. I mean, I've spent a lot of time in vets' offices. And then in order to do the drug doses calculations, you're going to have to convert from pounds to kilograms. I used to, years and years ago, I worked in this little clinic out in cells. And this was many, many years ago. And I worked there, and I just did intake. People would come, they'd walk in, I'd ask them to fill out their paperwork, and I'd weigh them. And the balance they had there, I think they must have got it from Mexico at the time, because it was only in kilograms. It was not listed, and there was no pound bar on it. So I would take the weight in kilograms. And I remember the first time I did that, the white-haired doc there just about screamed at me and said, "Look, I don't want to hear their pounds and kilos, their weight in kilos. I want their weight in pounds. I don't want to hear that kilo stuff." So I would always have to do the same thing. I would take their weight in kilograms and I'd multiply it. Would take their weight in kilograms and I'd multiply it by 2.2 to get their weight in pounds. And like this equation here says, if you know their weight in kilograms, sorry, I said that backwards. If you know their weight in pounds, then you're going to get their weight in kilograms by taking the pound weight and dividing it by 2.2. If you know, and I mean, I know it's 2.2 something, but 2.2 is fine for me.
Good enough.
If you know the weight in kilograms, then you multiply by 2.2. So my 10-kilo cat, Mr. Mouser, well, when you multiply anything by 2.2, all you do is take the decimal place and move it one place to the right. So 2.2 times 10 is 22, which I won't go through this all again because we looked at this the other day. Okay. Here's another calculation. If you weigh 220 pounds, what's your weight in kilograms? Well, if we know pounds, then we're going to have to take the weight in pounds, divide it by 2.2 to get your weight in kilograms. And honestly, if anybody asks me my weight, I always express my weight in kilograms. It seems like less. Like if you're on one of those dating sites, you should always list your weight in kilos because you're going to seem much lighter. Now me, if I was to do that, I'm sure somebody would send me an email back and say, "Look, you look pretty fat for a 100-pound guy." And I would say, "Well, no, I'm not 100 pounds. I'm a biologist, a scientist. Didn't I tell you? I listed my weight in kilos, of course." But it's always less. So I seem less massive that way. Now, if you do work through the lab, you have already done some of these calculations. But if your patient weighs 132 pounds, what is their weight in kilograms? Well, this one's pretty easy to do. You know their weight in pounds, 132. You're going to divide that by 2.2, and their weight in kilograms is 60 pounds. 60 times 2.2 is 132. And then the question, if you weigh 70 kilograms, what's your weight in pounds? Well, if you know the key weight in kilos, you have to multiply by 2.2 to get your weight. And I'm pretty sure when I wrote these questions, I made them so they came out in nice round numbers. So 70 kilograms, whoops, turn it on. 70 times 2.2 equals 154. Right, so we multiplied by 2.2. Your doggy patient could be, weighs 99 pounds. What is her weight in kilograms? Well, I'm going to give you a second to think about it. Weighs 99 pounds, but we want the weight in kilos. Now, remember, the weight in kilos is always going to be less. So, because there's 2.2 pounds per kilogram. So if you weigh 99 pounds, well, I don't know. every time I'm in the vet's office, there's always a calculator somewhere there. 99 divided by 2.2 equals, did anybody get it? Come on, somebody tell me what it is. 99 divided by 2.2.
Is that 45?
Excuse me?
45.
45, exactly. Yeah, I made every one of these questions. I didn't want to have numbers like 45.37. Nah, I made them all nice and even. But you're right. The dog would weigh 45 kilos, which is 99 pounds. All right, now, so the thing is that you will need to make these calculations. I don't know. I've spent a lot of time in Rocky Point for many years, and sometimes I would see things at the grocery store, and their weight, I mean, their price would be in kilos. It'd be like, you know, $1 per kilo for some potatoes, let's say. And so if it's $1 per kilo, I would kind of think, well, wait a minute. If it's $1 per kilo, then it means it's $1 for 2.2 pounds, which means it's about 40 cents a pound. Is that a better deal than if I bought it in the U.S.? Of course, then I would get it to the border and they would confiscate it all. But anyway, sometimes I thought I got a great deal on something down there because I was able to convert from pounds to kilograms. But absolutely, when you see drug dosages, you're going to see drug dosages that say something like administer 5 milligrams per kilogram of this drug every 8 hours. That's the way the drug doses is going to be listed, 5 milligrams per kilogram. So let's just say the person weighs 100 kilograms, right? That's 220 pounds. 100 kilograms, you're going to need to give 5 milligrams per kilogram. So that's 5 milligrams times 100. 5 milligrams per kilogram times 100 kilograms is you're going to give 500 milligrams as a dose. And I've included some questions like that in the lab that were, you know, designed to sort of show you what some of the real calculations are going to be like. Because I have seen people in a vet's office in which they are trying to calculate out dosages, and they often, what's great about that is that they can turn to somebody else and go, hey, would you double check my math on this? Because obviously you do not want to be the one who has to explain that you made a mistake in the metric system and you accidentally killed someone's dog. I would not want to be having to say, yeah, we accidentally killed your dog. We gave him the wrong dose. And you can do the same thing, of course, with a human being. So these are the reasons why we want to be careful about that stuff. Okay, and I think that's the end of that PowerPoint. So we'll be extracting questions directly from this PowerPoint to put on the quiz, no doubt about it. Okay. Did I change anything in here? Ooh, I'll save it. Yeah, if I don't remember changing anything, but I might have. All right, so I'm done with the metric system PowerPoint, but you've got metric system stuff to work on. And I want to remind you again, the metric system never comes off the table. If I write a quiz and I can't think of anything to ask you about, I'll ask a metric system quiz. Any kind of metric system question. Could be a metric factoid, like, you know, how is a gram defined in the metric system? Well, how is a gram defined in the metric system? A gram is defined as the weight of 1 milliliter of liquid water. Let me put that on the chat. And that's not my tail that you see back there. That is somebody else's tail. I actually think it's mousy. Okay, so here we go. A gram is the weight / mass of 1 milliliter of liquid water. Notice I, of course, included the liquid part. Mouse, don't stand on that computer, please. No. When I was, you know, if you read about me on ratemyprofessor.com, which you might, I suppose, where are you doing? You might read something that says that Steve Mackey talks about his cats in class. Well, it's true, I do. I'm an ilurophile, which is a fancy way of saying a cat lover. I like cats. I really like cats. I study cats. I study the biology of cats, and I study the biology of bobcats, etc. But the bottom line is that I've never brought a cat to class. Well, now I notice when I do virtual classes that some cats come to visit me during class, and that's not good. Come on, Mouse. I barely lift you. No. I apologize for the interruptions by my cat. So did everybody see my definition of the gram? A gram is the weight or mass of 1 milliliter of liquid water. That will help you answer some questions. Now, you know what? Just got to say it. Every once in a while, a student will say to me, you know, Steve, what an amazing coincidence. What an amazing coincidence that a gram just happens to weigh it just so happens that 1 milliliter of liquid water weighs 1 gram. What an amazing coincidence. And I have to point out, oh no, it's not a coincidence. That's the definition that they used. And I like that. That's an elegant definition, I think, to base it on a property of water. Water being one of the 5 major biomolecules, and water being one of the most common and amazing molecules on the planet. I will give an entire lecture on water and its incredibly amazing properties. So to think about, I just wanted to be clear, it's not a coincidence. This is the way they defined it. They said the weight of 1 liter of liquid water is 1 kilogram. But that's exactly the same as saying that the weight of 1 milliliter of liquid water is 1 gram. The correspondences are the same there. Okay? So just so you know, I mean, I could have written that definition. A kilogram is the weight or mass of 1 liter of liquid water, but I think it's easier to recognize that this very important correspondence that a gram is a weight or mass of 1 milliliter of liquid water. Okay, so write that down in your notes if it's not pretty clear and explicit. Okay? All right, so let's move on. I want to move on to a new topic and a new PowerPoint. It's right here. And this is about the scientific method. Now, very soon, I mean, probably starting the next time, I'm going to start talking about some real biology, right? The characteristics of living things, life, that kind of stuff. But you probably remember that I defined biology as the scientific study of life and organisms. Sorry, every once in a while I think, am I presenting? Yes, I'm presenting. So I don't know why. Somebody will certainly tell me if I am not presenting, I'm sure. Okay, oh, please just holler it and say, Steve, I don't see what you seem to be pointing to.
That is all right. You're presenting.
It looks okay now, right?
Yeah.
Science and the scientific method. So we have got to talk about the process of science. I mean, for lots of reasons, but one reason is that that's one of the things I need to talk about in Bio 156. One of the many things I need to talk about in Bio 156. And here's the thing. As you already know, you're training to be a biologist. And biologists are scientists, and they use the scientific method to answer the questions that they have. The definition of biology was the scientific study of life and organisms. So we need to talk about science and the scientific method. And this PowerPoint is available for you. You know, it's already posted so that you can take a look at it and study it. So The topic is science and the scientific method. And the first question is, what is science? Because amazingly, even though you and I live in a very scientific technological society, and what I mean is we're surrounded by science in some respects. I mean, we live in Tucson, Arizona, which is a big science town. But if you're surrounded, you know, we're surrounded by science, but we're all surrounded by what I would like to call the fruits of applied science. And what I mean are things like our cell phones, our computers, our televisions. I mean, all the technology that we are surrounded by, it originally was basic science. I mean, I'm trying to imagine what it would have been like for some material scientists to realize that he'd created a material that was responsive to human touch. And he probably thought, well, that's amazing. It's responsive to human touch, and published some papers on this unique material. But someone else went, wait a minute, responsive to human touch. Maybe we could make a computer that you don't even need to touch the keyboard. You can just touch the screen made of that stuff and it will respond. Of course, cell phones, the surface of cell phones, all you have to do is gently touch them and they respond to your touch. I mean, somebody took that basic science, a material that would respond to human touch, and used it to create technology that we're all used to using every day. Technology like that, it doesn't appear without basic science deep behind it. That's the only thing. So we live in a scientific technological society, yet most people do not really know what science is. I mean, they've heard the word, they kind of have some things they think of as attributes of science, but they don't really know exactly what science is. So I want to answer the question, what is science? And, oh, here's one of my favorite quotes. Scientia potentia est. Latin, scientia potentia est means knowledge is power. And so scientia in this case is derived from the science, and scientia derived from a Latin word for knowledge. Potentia really means power, like potential energy or potency, and the S is just is. Knowledge is power. So at some level, science is knowledge. It has to do with knowledge. I can't deny that. But I fundamentally think that science is a tool we use to answer certain questions we have about the natural world. Science is a tool. It is a critical thinking tool that we use to answer questions we have about the natural world. You know, humans are very curious at organisms. Really, mammals, and we're certainly mammals, and most other organisms are curious about the world. And humans are absolutely in that same category. What we do as soon as we're born is we create what I like to call our toolbox that we use to answer questions we have starting as soon as we are born. I mean, we are born with a curious mammalian brain that generates questions about the universe and tries to answer those questions. So what are some tools that we all put in our toolbox? Well, here's some. Like, one of them is what I like to call the Ask Mommy Daddy tool. I mean, that is one of the very first tools we use, the Ask Mommy Daddy tool. Our parents seem to know everything. We ask Mommy Daddy, and that's where we get some of our first answers. You know, there's a period of time that kids go through. Maybe some of you have been blessed to have the ability to experience this with your own children, where they constantly ask questions like, why is the sky blue? And why did the cat do that? And why did that fall over? And why does Daddy have to go to work? And all these kinds of things. And the very first source of information is Mommy Daddy. Now, when we get older, we may develop a different tool, probably do, called Ask Dr. Lawyer. You know, where we basically go, oh my gosh, I've got this horrible pain in the side of my face. I'm going to ask my lawyer if there's anybody I can sue. But the bottom line is that you as we go older, we get these. You know, I have friends who one of their things they have in their toolbox is this thing they call meditation. And honestly, I'm not sure I totally understand it, but I've had friends, and I've said, "Look, you want to go to the movies this Friday?" And they'll look at me and they literally go, "You know, let me meditate on it." And I don't know exactly what that means, but I kind of picture them, you know, sitting in a lotus position and using this mantra, you know, like movie Friday. I don't know. But anyway, meditation is something you might put in your box because for some people that might be an essential way they ask questions. Now, in that same toolbox, you could put some ancient religious text like the Bible or the Torah or the Quran or the Tao Te Ching. You could write poetry. You could write music. Oh my gosh. Google, that is one of my major tools in my toolbox nowadays. You know, I got to tell you this, you're probably not going to believe this, but when I was your age, mostly the average age, right? There was no Google. Google did not exist. And now, if I have any question whatsoever, you know, like what is the nutritional content of an avocado? I Google it. I don't ask my mommy, daddy. I don't consult the Bible to find out the nutritional contents of an avocado. I don't meditate on it. I Google it. So, I mean, what I'm trying to say is we create this toolbox that we use to answer questions we have starting as soon as we were born. And science is one of those tools that we can choose to put in our toolbox. Now, when does science work best? That's the real question. Scientific method works best when we're asking questions and expecting answers in the concrete, measurable, accountable, weighable world, the world of our senses. You see, science works best when we can count, measure, weigh things. Physical, concrete, measurable things. The world in which we can use our senses, you know, hearing, vision, touch, to experience something in the physical world. Now look, is every question we have about the concrete, measurable, countable, weighable world? No, it isn't. But there's lots of other tools that you can use. The scientific method works best when we are working in the physical, material world and we're expecting answers about things we can measure, count, and weigh. Now, there's tons of things we can measure, count, and weigh. I mean, there's a lot of our world is made up of physical things that we can measure, count, and weigh, no doubt about it. So the bottom line is that science is a reasonably good tool to use under those conditions. You know, my sixth grade science teacher had a definition of science that I really like. He said this: science is the systematic search for truth through observation and experimentation. And I like this definition of science for lots of reasons. You know, I've shared this definition for with many people, many students, thousands of students certainly, and sometimes and with instructors too. And if there's any word that bugs a scientist in this, it's this word, truth. And I put it in quotes because here's the thing. My sixth grade science teacher, I don't think he had a lofty idea of what this truth word means. He meant that if you're going to try and answer your questions, then what you would like to find, if possible, is the truest answers. So the search for truth here is really, it really means that you are trying to find answers to questions you have. And if you're going to go through the trouble to try and find those answers, you might as well try and find the truest answer in the group. Now, I've put truth in quotes here because the word truth in the realm of science is a little controversial. And that's just because we know that when we do the scientific method, we are very careful to describe something as true unless there is just an overwhelming amount of evidence to suggest we should call it true. Most science strives to get as close to the truth as possible, and then says, this is the best answer we have today. Maybe someone will be born tomorrow who has such a clever brain that they will figure out a better answer that we all missed. But, you know, my 6th grade science teacher was a pretty pragmatic guy. And he actually said something that I remember to this day because it was sort of profound. He said, look, for any question that you have, there are multiple possible answers, always. Multiple possible answers. I mean, you ask somebody, do you like pizza? And here's possible answers. 1, yes, I love pizza. 2, no, I don't like pizza. 3, I can take or leave pizza. Other person would say pizza's not very healthy for you. I mean, multiple possible answers. This is always the truth. When we, in scientific method, we absolutely try to create a list of possible answers and then work our way through that list of possible answers and keep the best possible answers and eliminate the worst possible answers. That's part of what science does. Now, I want to emphasize something that I should have emphasized back here, right? Where I said science is a tool used to answer certain questions we have. I don't want anybody who's in the listening audience right now to think that Steve Mackey has gone on the record by saying that science is the only tool. No, that is not true. Science is one tool. Can science answer every question that we have? No, it cannot. It can answer certain questions that we have. And those questions are going to be about, you already know it, countable, measurable, weighable things. Okay? That's where science works. Some questions, science isn't very good at answering, I don't think. You know, anytime I hear about somebody doing a scientific experiment about love, I get nervous because I think, really? How can we measure, count, or weigh love? I mean, is there a love-o-meter that will give us information about how much love someone is exuding or having? No, there is no love-o-meter. The only thing I've ever seen that people use to know if somebody loves them is what I call the flower tool. Maybe you've seen it. It's where you pick up a flower and you go, she loves me, pluck. She loves me not, pluck. She loves me, pluck. She loves me not. You get to the last petal and it's she loves me not, and I guess she didn't love you, right? Well, that's the only mechanism I know. So if you can't count and measure, weigh things, then you're going to have to work hard to convince me that you can even use science as a tool. But I will say this. The one thing I hear all the time is that we don't give students the opportunity to learn how to do critical thinking. We need to critical think more. We need to have skills in critical thinking to meet the technology and the challenges of the upcoming world. We need critical thinking skills. Well, let me tell you, science is a critical thinking tool. If you understand how to do science, you will understand how to do one critical thinking tool. And if someone was to say to you, hey, do you know how to do critical thinking? You could say, well, I know how to do scientific method, which is a type of critical thinking. All right, back to this. So, answers to questions is what search for truth means. observation and experimentation, that says to me very clearly, countable, measurable, weighable. If you can observe it critically, you can manipulate variables and do experiments, then you are, you're in the realm of the senses, the concrete world of the senses. The last word here is this word, systematic, and I like systematic. What the word systematic means is probably what you'd already expect. It means there's a system that you use to do science. It's not random. You don't do it in sort of a stream of consciousness way. No, there is a system for doing science. A set of steps, a set of rules. There is a system for doing science. And that system is called the hypothetico-deductive scientific method. That is the system that we use to do science. I know this is the big expanded version, hypothetico-deductive scientific method. You might just refer to it as the scientific method, but I like to include these words hypothetico-deductive in it because it refers very specifically to two of the steps in the scientific method. Hypothetico refers to the idea that we make hypotheses, and deductive means that we make predictions based on those hypotheses. So there are 7 steps in this classical method of doing science, okay? 7 steps in the hypothetico-deductive scientific method. The process of doing science, technically, you don't even do it unless you have a question you really want to answer. I mean, it springs out of curiosity, just like any of the methodologies you have in your toolbox would, right? I mean, you don't ask mommy, daddy a question unless you're curious and you have a question. You don't ask Dr. Lawyer a question. You don't Google unless you have a question. And it's the same thing with science. In this classical method of science, we don't really say that one of the steps is that you generate a question in your mind, because why would you reach into your toolbox to answer questions if you didn't already have a question in your mind? Okay, just to be clear about why I don't include this. Now look, if you go and Google scientific method, which I encourage you to do, you will find that there are some versions of the scientific method that start before square one, in my opinion. And they literally say scientific method starts with an observation. Well, you know what? If we observe something and we generate a question about it, that's when we go, where's my toolbox? Where's my question and answer toolbox? And then we reach in and we decide, how am I going to answer this question? Am I going to Google it? Might be a good idea. Am I going to meditate on it? Am I going to ask, am I going to get one of these ancient authoritarian religious texts and do it that way? How am I going to answer the question? And that's when I might think, well, it seems like this is about countable, measurable, weighable stuff, so let's try science, because there's a nice systematic way to do science, and it probably, that systematic way will reveal whether science is the right version, a right tool to use or not, okay? So here's a document that is called The Big Picture of Scientific Method, and I'm getting ahead of myself a little bit here, but that's okay. I would like to talk about this document that I put together called The Big Picture of Scientific Method. And for what it's worth, we're going to talk about the steps. Step 1, Step 2, Step 3, Step 4, Step 5, Step 6, Step 7. We'll talk about all of these steps, and we'll come back to this again. But what this shows you is that we start with a research question that we have, like, are cats smarter than dogs? Right? We do our best to refine that question and make it as clear as possible. If you ask the question, are cats smarter than dogs, you might need to worry a little bit about how you're going to measure smartness on animals. I mean, what tool would you use to measure smartness? You're also going to have to think about, how am I going to decide whether cats are smarter than dogs? Am I going to get the average IQ of 10 dogs and the average IQ of 10 cats and do a t-test to test the averages and see if they're the same or different? You see what I mean? With the research question, there's always parts of a research question you need to think about it. Now, then you'll move on to step number 2, where you'll literally explore the research question for the purpose of understanding it better. Then step 3 is where we generate possible answers to the research questions. These are called hypotheses. This is plural, or one hypothesis. But as you'll see in a minute, a hypothesis is one of the possible answers to a research question. That's what it is. Okay, that's the best definition of hypothesis. Hypothesis is one of the possible answers to a research question. Now, once we have hypotheses, which tend to be kind of general, you know, they're vague in a certain sense, and I'll explain what I mean, then we will generate predictions about measurable, countable, weighable things. We're going to say, look, if this hypothesis is the best one, then when we, you know, do a doggy IQ test on dogs and a cat IQ test on cats, and we do it for 10 cats each, and we take the average and use a statistical test to test it, then we should find this, right? Predictions, pretty specific. We test those predictions to do experiments. We analyze those experiments, and really what we mainly do when we analyze experiments is we ask, were the predictions true or were the predictions false? If a hypothesis makes a true prediction, then we say it's a supported hypothesis, it's a useful hypothesis, we'll keep it for today. If we discover that a hypothesis has made false predictions about measurable, countable, weighable things, well, then we have shown the hypothesis is false. We've rejected it. It goes in the trash, right? Not lastly, but as part of the whole system, we do something called peer communication. Now, let me just mention this part down here at the bottom because there's a thought question about it. And this is a pet peeve of mine. It drives me crazy when I'm watching shows, even science shows, and people use the word theory wrong. Right? They use their theory wrong. If a forensic scientist walks in the door and sees a body lying on the floor surrounded by blood, they really aren't going to generate any theories right away. They're going to generate hypotheses. They're going to go, okay, this person had a heart attack, fell, cracked their head open, and that's why there's blood everywhere. Or this person was stabbed by a knife, and that's why there's blood everywhere. This person was shot by a gun, and that's why there's blood everywhere. And this person, fell on a broken bottle, and that's why there's blood everywhere. These are hypotheses. They're possible answers. Hypotheses can be good or they can be awful, right? One hypothesis might be that a person walked in their front door, saw a giant pool of blood, got so freaked out by it that they passed out right into the pool of blood, cut their head open and added to the pool of blood, and that's what killed them. That's one possible hypothesis. I want to be clear. A theory in scientific method is a much higher level of understanding. It's much higher level. You never generate a theory in 5 minutes, 10 minutes, or even a year. You don't really. A theory is a well-tested hypothesis that has only made true predictions, and it usually has to be tested and tested and tested and tested and tested. So I'm sorry to say I drive my wife crazy with this all the time, because on TV, on science shows, which I watch, they'll go, Yeah, I've got a theory about that. I heard that whale screaming all night, and now I have a theory about why. I want to go, no, you don't. You don't have a theory. You have a hypothesis. You're going to need to do the scientific method and test to see whether the hypothesis is a good hypothesis or not before maybe you do lots and lots of tests and you promote the hypothesis to a theory. A theory, again, is a really well-tested hypothesis that has managed to make only true predictions, and it's a higher level of understanding than just a possible answer to the research question. You know, if you go out and you try to start your car in the morning and it doesn't start, you're going to generate a list of hypotheses. And if you said, you know, one hypothesis is that I'm out of gas, that would be great. But, you know, technically, if you're a scientist, which we're all training, you're training to be scientists, you wouldn't say, you know what, I've got a theory about this. I think my theory is I'm out of gas. No, sorry. That's not a theory. That's a hypothesis. Oh, and I know, you know, I'm a biology teacher. I've been thinking about science, been a working scientist for many, many years, and so it just irks me when I hear this used incorrectly. And part of the reason is because I've heard people say to me, well, Steve, that's only a theory. And I go, yeah, it's a theory. It's the cell theory, which was first proposed as a cell hypothesis in 1839. It's been tested and tested and tested and tested for 180 years. And now we call it the cell theory because it's never made a false prediction. I know. It's me being crazy, right? Okay, here we go. So, step one. Step one in the scientific method is create a carefully worded and precise research question. But first, I'm escaping for a second. So I can see who's actually asleep. Hey, I can't see you. But the bottom line is that, are there any questions on anything we've covered so far?
I kind of have one.
On the metric system, on the definition of a gram, any of that.
Can you hear me?
Just go ahead.
Oh, so it sounds to me like a theory is a lot more of a known quantity than I've ever been taught before. For a theory to be turned into law, what's the difference there?
Oh, good. Well, thanks for asking that. Here's the thing. You're right. It's like there's levels. There's a hierarchy. The lowest level of an answer is a hypothesis, right? And again, I'm going to say it. When you generate hypotheses, you absolutely expect for there to be, well, you hope that there's some good hypotheses, some useful, testable hypotheses. But you also expect on a list of hypotheses for there to be mediocre, maybe even stupid or silly hypotheses. That's okay. That's normal. We encourage people to make a long list of hypotheses, and we acknowledge that it's totally normal and typical for some, we hope, to be good ones that survive testing so that we have a sense that they're pretty good, and some that are so awful they're going to be eliminated very fast, which we'll talk about how to do that. But then, if you have a hypothesis and you test and tested and tested and tested and tested, then maybe you're going to decide this is such an important idea that we're going to elevate it to a theory, and that is a promotion for it. But, you know, I really am going to say you don't get theories in a month. It may take years for things to get to be a theory. And again, I'll say it. One of the main theories I'm going to teach you in biology is called the cell theory. And the cell theory was first proposed as a hypothesis in 1839. And then it was tested and tested and tested. I mean, it was tested like crazy. It was called the cell hypothesis. And now we call it a theory 180 years later after it was tested and tested and tested. And honestly, in biology, theory is about as high as we generally get, right? We get to a certain level, theory is about it. Now, in some other sciences, mostly physical sciences, where we're dealing with very countable, measurable, weighable, even very predictable and I don't know what the word I'm looking for here is, but in those conditions where we're dealing with physical hypotheses, physical theories, that's the realm. I'm talking about chemistry, geology, physics, astronomy, where things are pretty well behaved. And when I say things, I mean matter and laws, and matter and behaviors and characteristics and properties are pretty well behaved. In those disciplines, sometimes they can see that a theory is really a super high level explanation or answer. Sometimes you even see that multiple theories can be integrated together, and that's when you create a law, like the laws of thermodynamics, the laws of matter. I mean, these laws, they represent another level of deep understanding of the natural world. And again, I can't actually tell you a single biological law, because I mean, you know, there's things like Mendel's laws of inheritance, but they're not really laws. There's Mendel's hypotheses. It's a misuse of the word. A law is the highest level. A theory is below that, and a hypothesis is below that. But great question. Thank you. And again, so it kind of begs the question of, well, why in biology don't we have laws? And you know, this is just my opinion, okay? My opinion is that biological creatures are radically different than other elements of the natural world. Biological creatures actually are so variable in a predictable way that it's very difficult to coalesce their characteristics or behaviors into something that's so universal and constant that we would declare it to be a law. A theory is about as high as we're going to get in biology. I mean, I will teach you about this, but biological creatures do this thing called sexual reproduction. And not all do, but many biological creatures do this thing called sexual reproduction. And one of the ultimate goals of sexual reproduction is to shuffle the dice again and again and create brand new, unusual outcomes and connections between things. And that means that when we study biological creatures, we expect there to be variability, you know, built in. And you might even think of that not just in terms of variability, but look, some biological creatures, they're just ornery. They want to defy being lumped together and classified together. And that may be one of the most interesting things about biology. I mean, I find things about astronomy interesting. I find things about geology interesting, or physics or chemistry. I find chemistry very interesting. But there's something really fascinating about biology, because biology is so, it has this kind of quirky, unpredictable, variable nature to it that atoms and molecules just generally don't have, right? You can create laws about atoms and molecules because they're very well behaved. 2 sodium atoms are going to be identical in all ways. But are 2 cats going to be identical in all ways? No. They're going to be genetically different in many respects. So, kind of I mean, I appreciate your question, and I'm sort of acknowledging that when it comes to basic bio, one of the fascinating things for some people in basic bio, myself included, is that biological creatures sort of try to defy what we might consider some of the, you know, kind of basic behavioral properties of matter, and that's just built into them. But great question, thank you. So any other questions, though, about scientific method? Again, I want to be real clear that if you have a question like, are men taller than women? Well, that sounds like we're going to classify a person as a man or woman. We're going to measure their height. We're going to compare the heights using some kind of statistical test, and we're going to get an answer to that question, right? We're going to either discover that men are taller than women are taller than men, or men and women are the same height, you know, from a statistical perspective. And so science sounds like it would work there. If we ask a question like, what is the meaning of life? Well, you know what? Science isn't going to answer that question for you, because the answer is probably not going to be in a countable, measurable, weighable thing. In that case, well, you could Google it. I've asked Google, you know, one of those machines, you go, hey, Google, what is the meaning of life? And, oh, it will go on and on explaining the meaning of life to me. But honestly, that might be one of those cases where you want to consult one of those ancient authoritarian religious texts, because probably the Bible tells you what the meaning of life is, or the Quran tells you what the meaning of life is, or the Tao Te Ching tells you what the meaning of life is. But, you know, that's why we have multiple tools in our toolbox. And I don't expect any tool to be useful in all cases. You know, I wouldn't ask the Bible if men are taller than women, because I don't think I would find an answer to that question there. I could ask Google, and Google might then spout some scientific study, but all right. I just want to make sure that I shut up long enough for somebody to school the word and edgewise. And somebody said to me the other day, I don't know how you can teach that long. How could you possibly lecture for 4 hours? And I went, you know what? I can lecture for 4 hours. I've got enough material to present. I can lecture for 4 hours. I'd rather not. It's too long to lecture, but oh well. Well, where was I? I was talking about one of my favorite things to talk about, scientific method. Step one. Now, we've already got a question in our mind, right? We've already got a question. Are men taller than women? Are cats smarter than dogs? Why won't my car start? So the first step is we try to create a carefully worded and precise research question. I use capital R, capital Q as an abbreviation for that, for research question, and you can certainly go ahead and use that too. All right. How do we create a carefully worded and precise research question? Well, one of the easiest things to do is to just look at the question and ask yourself, what words, ideas, concepts in this question might require some description, clarification, identification, criteria, or explanation? Because any word, any question that you have, remember, is likely to be a rough draft when you first create it, but you're going to have to turn it into a better draft in order to make it an answerable question. Well, let me tell you right away that one of the most basic ways to create better and carefully worded and precise research questions is to ask for help from your scientific peers. Ask for help. This is an essential element of science, And in fact, what I just brought up here says see step 7. And what I mean is step 7. We're in step number 1. But I'm now saying to you, look, in step number 1, there's a really good chance that you would benefit from seeing step 7 and thinking about step 7. So what is step 7? Step 7 is called peer communication. So I've just jumped from step 1 to step 7 for a really good reason. Step 7 is called peer communication. And of course, peer means your fellow scientists. The process of science is a social activity. It's social. Don't think that scientists, working scientists, are locked up in some ivory tower somewhere where they can't communicate with other scientists. No, that is not the truth. Science is a social activity. When we do science in a class, we often do it in an interactive way with other members in a lab team. I mean, honestly, this is one of the things we have a hard time doing in a virtual environment, though it's probably just something that somebody smarter than me would know how to do. But look, it's absolutely necessary for scientists to interact with their scientific peers. That means your research team, your colleagues with science training, your lab partner. I mean, peer communication means that you are communicating with other scientifically trained peers. There's 2 main types of peer communication: formal and informal peer communication. Right, so let's talk about that for a minute. Formal peer communication is the one we often think about. It's where you present your work at a scientific meeting or a conference. Maybe you even publish a peer-reviewed scientific paper in a scientific journal. Now, it's true. Formal peer communication usually happens towards the end of your scientific study. You know, it's very rare, unless you're, like really famous and you're going to go to a scientific meeting and you're going to talk about your research question. It's really rare. Most formal peer communication happens towards the end of your scientific study. Okay? Now, informal peer communication happens constantly throughout your research project. It happens starting with step 1, right? You are going to ask for help and advice from your fellow scientists. That is absolutely considered an essential part of the scientific method. It's used in every step 1 through 7. You can ask your peers, hey, could you look at my research question and tell me what words or phrases or ideas in this question are not as clear as they could be? That is totally and completely expected. If you work in a lab setting, I've been really lucky. I've been able to work in a lot of labs over at the U, and there's always a bunch of people working together on similar ideas there, and those people are constantly talking. They talk about their own research. They talk about other people's research. They have meetings where they discuss their research, other people's research. They're constantly getting feedback from their fellow scientists. Informal peer communication is used in every step, and what it means is one day you will ask for help about your science, and the next day someone else in your research group will ask for help about their research. The last lab that I worked in, I probably would have worked there this summer except of COVID-19, is a cat genetics lab at the U. And when I say cats, I'm talking about wild cats. So people there study mountain lions, tigers, lions, fishing cats. I was part of a project there called the Bobcat Project, and we studied the population genetics of bobcats in Tucson, Arizona. But those people were always talking to each other. And what was great was, of course, you were working with people who understood basic biology. They understood basic cat biology. They understood science and scientific method. They understood the technology around gathering data about wild cats like jaguars and mountain lions and those kinds of things. And so you were talking to people who had a body of knowledge that was exactly related to your work. And that constant chatter was the way that step 7 is used in every step 1 through 7. Okay. So any questions about that? You saw what I did, something kind of weird here, right? I started with step number 1. But when I went from step number 1, I said, look, you know, that we have to, it is absolutely normal for us to go from step 7 to from step 1 to step 7 because of peer communication, which happens, as I eventually came to and said, look, it happens in every step. You could ask for help in creating hypotheses. You could ask for help in creating experimental designs, in creating predictions. It's expected that you would do that, right? A scientist that can't bounce his ideas, his or her ideas, off of other scientists is at a great disadvantage in the scientific community. Great disadvantage. Okay, so that's where we're jumping from. That's why I jumped from step 1 to step 7. All right, but next I'm going to go back and start talking about step number 2. Okay, but you know, again, the idea that you would have a class like this and I would lecture for hours and hours is kind of not what I really want to do. So I'm going to divert myself a little bit here. And if anybody has any trouble following me, I hope you, you know, you'll ask me a question. All right. This PowerPoint is posted. It's a long PowerPoint. It's 29 slides. We're on step number 9 now. Excuse me. We're on slide number 9. And honestly, I'm pretty sure we're going to pick up right here again tomorrow for sure. But I need to actually talk about a labby thing that I would like you to think about. Okay, there's a labby thing I would like you to think about, and so I'm going to reduce this, and I'm going to. I want to look at this document called Alka-Seltzer Science at Home. Okay, but again, I need you to just get up and stretch and walk around for a few minutes, okay? So I'm just going to take a quick break, and I'm going to take a quick break, and then we're going to come back to this document. And I'm not sure this document is posted, but believe me, as soon as we go to work, I'm going to post this document so that you can look at it, okay? Because I don't think it's actually posted yet, but I'm going to get it posted, okay? But for the next 10 minutes, we're just getting up, stretching, moving around, getting some more caffeine, whatever it takes to, you know, survive for a little bit while. And to explain what we're doing here and when we're going to stop. And then you're going to use the last 15 minutes of class or a half hour or whatever of class, you're going to use that to work on this a little bit and think about this so that I'm not lecturing at you for 4 hours and ruining your brain. Okay? All right, so 10-minute break. I'll be right back.
Ay, ay.
All right. I'm back. Sorry. Guess it was a little bit longer than 10 minutes. But so, like I said, I'm going to post this document as soon as we end class today in a little while. And I'm going to ask you if you would to take the remaining class time and think about this document. Believe me, I will post it. You know what? Give me a second, because yes, go ahead.
Really fast. So so on the lab that is due tomorrow, I didn't accept that there's the one, like the physics site with the, I don't know, the ruler and all that stuff.
Right.
There was one for graduated cylinder measurement, and the link didn't work. I fiddled
Oh,
around with
really?
it. It just seems like the exercise doesn't exist. Like I typed in keywords, and so that was the
Wow.
only thing I couldn't complete on that lab.
Wow. Well, did anybody else have that experience?
I finished mine and my side did work.
Weird.
Did work.
Yeah.
And
Mine didn't work either.
it didn't.
So I had the same issue, but what I did, I went into like the whatever it's called, I can't remember what it's called, the online thingy, and I just pressed download, and I did it through like a Word document, and it let me like press control and then click on it, and it took me right to the site.
Really?
Yeah, right. But it's the actual link that's so I click on it, it takes me to the site, but then it just says that you like that the exercise just isn't there.
Oh.
Yeah, it kept saying like error for me too.
Yeah, and I went and I did like a keyword search for like the graduated cylinder, and again it was just there was no results.
Wow. Did you type the whole thing?
Yeah, I typed in the whole thing. I typed in graduated, I graduated cylinder. I'm like, so
Yeah, I typed it in and then I tried copy and pasting it, and it didn't work.
I did the control thing. Yeah, it's just, and it was just that one. Like all the other ones worked beautifully.
Everyone else worked fine. Huh.
Everything else worked fine. It's almost like the exercise got deleted off the site itself.
Well, that is crazy. Well, look, we're fortunately in a position, I think, where I can. Well, I'm just curious now that everybody has said this. When I did it, I didn't have any trouble doing it. But, well, I'm telling you, when I did it, I didn't get them all right. I mean, I went through it, and then I was kind of. I thought, wow, I guess I didn't understand the kind of estimations that.
The ruler one was really wacky. It just like it told you could move it, but like I thought at the beginning you were supposed to line it up with the edge of the block. Apparently, like I figured it out. You just had to like subtract the small value from the large one. That was really whack, but I mean, I figured that one out at least.
Right.
I still haven't figured out the ruler one.
The ruler one is not working well either.
Yeah,
no, I just don't. I can't like I've tried everything, and it seems like I get every single answer wrong.
Right.
Yeah. So what you have to do is just don't move the ruler at all. So it'll on the left side it'll be like 3.4 or whatever, and then the right side it'll be like 33.4. Just an example. So you take the 3.4 away from the 33.4 to get like the 30 inches or centimeters or whatever. So just like don't move the ruler.
Okay, I'll try that.
Bizarre. It's really
what you're saying is that you can't, since you can't move the ruler, you have to go, okay, there's this little piece at the end that looks to be about half a centimeter long or something like that. And wow, that's crazy.
And like the weirdest thing is that you can, so very occasionally it won't line up properly, so you put the small arrow to line it up, but at the same time you still put it at like 0. You just subtract like the starting value from the ending value.
Well, I don't know what's going on. Somebody okay? Sounds like somebody fell off their chair or something. Everybody okay out there?
Again, I don't know if that should work, but I just sent it through the message.
Oh, cool. Thank you. Let's see.
Okay, so I mean, here's the.
Oh yeah, that's weird. That link works. Okay.
Okay. Yeah. Yeah, 'cause I pressed the top where it says the HTTPS and it took me to a different site. But then again, I clicked the one with the programs, games, graduate cylinder. Then I pressed now and then it took me to a different one.
Interesting. Got you. Okay. Thank you.
Wow.
Perfect.
So this is what I just got when I just clicked it.
Yeah, that's the first one of, see how it says the physicssavery.com study. It didn't show the lack of the two graduated games.
Wow, you are right. Now this was brand new to me. When I did the graduated cylinder thing, it went straight to it. So that's just.
Yeah,
I mean,
and I
so-
did. I wrote in some notes that just a couple of the YouTube links put in have a little extra spaces so they don't work right away. If anyone was having trouble with that.
Oh wait, can you repeat that? With the
Oh,
YouTube?
I was just saying some of the YouTube links. I was just saying if they're not working, there on a couple of them there's like an extra space. So you just want to copy paste and then just take out like the extra space in the middle. You'll see it. It's obvious.
Okay.
So like
And then the YouTube link.
YouTube links are posted incorrectly. Like somehow when it was posted, it added in a space.
Yeah, just like right in the middle. So you'll have the YouTube.com link, and then there'll be like a little space, and then it'll put like index, and then like whatever code thingy it's called. I don't know.
Wow.
But yeah.
Thank you.
Well, and so I understand. I mean, what I just did, I remember the very first time I tested this out, it was maybe 3 weeks ago. It seemed like it went straight to graduated cylinder game, as they call it.
It's not all of them. So just a couple of them have the extra space. So I think it was just like a little typo or something like that.
Yeah.
Yeah, it's a pretty easy workaround. Luckily.
Uh-oh.
Nope.
What is going on now?
You've opened up the links.
I opened the link. It finally opened. That's the thing. Gee. All right, let's get rid of that.
Whoop.
Wow. How many times did I open it? 5
Quite
times.
a lot, apparently.
Yeah, absolutely. Well, so at least it opened. It seemed to be moving very slowly to me, but okay. So here's the thing about this lab. I mean, I'm going to be totally honest with you. I really appreciate everybody is trying to do their best work on this lab. And if you find that you just cannot do something, then I want you to notify me of that, and I'll see if I can solve the problem. But look, I feel like we're testing this lab, all the little links, etc. So what it comes right down to for me is that if you should turn as much of the lab in as you can, and if for some reason a link just refuses to work and you try every little twist and trick that you know how to do, then just let me know that, and I will give you the points for it. Now, what else, how else can I put it? I understand that the kind of new nature of this lab is such that the only way to really solve all the problems in it is to to have lots of people working on it. And if that means that I end up giving away a few points to people who can't, I'd be fine with that. So you just want to let me know. I don't want, because the lab is, is still in this sort of beta testing phase. If it doesn't work right, then you let me know that it didn't work right, and I will include that as part of the credit for the lab. Okay. I mean, believe me, it wouldn't bother me. It would not bother me in the slightest to give full credit to a lab if someone said to me, look, I did this part and this part and this part, but this part just didn't seem to work. You know, I'm going to still give full credit. Now, look, if you send me an email and said, Steve, I couldn't do any of the lab, nothing worked, I'm not going to give you full credit, obviously, because there are things that work. And I, you know, again, I personally, I'm not a computer expert by any means, but I know that sometimes when I look at something the first time, it doesn't run right. So I copy the link and paste it, and then it runs right. Or sometimes I try it a second time and it does run right. And I mean, I don't know if anybody else has ever had this experience with computers where they just seem to be ornery. But so please let me know if you've tried something. Yes, go ahead.
Hey, I got a question for you real quick. So when it comes to the lab, I'm good to go, but I just need to figure out where do you turn this thing in at? How you want me to turn it in?
Okay, so here's the thing. Has someone else who's turned this in, what would you say was the easiest way to turn this in?
So, I mean, I haven't turned it in yet, but my plan, I've taken pictures of what I have done, like everything we had to fill out on the paper, and just put it in an email, and I'm emailing that off. And then with the online, you know, exercises, I take a screenshot of my web page and attach that as a picture as well. But I'm pretty sure you can do it through D2L.
Well, that who has turned it in through D2L? Anybody?
There's nothing under assignment, so I was assuming you would just want to go through the email. I just sent mine through the email.
Okay, so that is a great observation. I mean, is there anybody out there who has been able to figure out how to turn it in on D2L? Anybody?
No, I don't think there's like a slot for it.
Okay.
Yeah, I don't think there's like a.
There has to be.
Yeah, you can do the student information sheet, but that's all you can turn in under D2L as of now.
Oh, that's interesting.
So I think like you have to be the one to set that up.
I do, and you're right. I do. How did I? And I have to admit to you how I thought I had set this lab up pretty much the same as I set up the student information sheet, but I probably made some tiny little error. You know how it is. I didn't check some box that I'm supposed to be really good at checking and whatever. But so,
so you want me to just email it to you? Then is that kind of what we're getting at right now?
That emailing it to me is probably the best way. Look, when you email it to me, you can remember there's multiple ways to do it. One thing you could do is you could download this entire document, then fill it in by hand, and then just attach and then just send it back to me as an attachment in an email, right? I think you could, it's a Word doc, so you download it, you fill it in, you save it as that same Word doc, and then you just send it as an attachment on an email. That might be the easiest thing, except that when you do some of these exercises like the graduated cylinder or the thermometer, it wants you to take a screenshot of your final answers, right? Mm-hmm. And that, that screenshot thing you can do in more than one way. You could take a screenshot using your cell phone and then send that as an attachment, or you can hit your computer, you can hit down and use probably the lower left, you hit Control, and up in the upper, there's a key that says PRTSCR, right? Most people have that PRTSCR. You hit Control, and then you hit a key that probably says on the top of it, it's probably right next to F12, or I hope. I mean, I'm working on a PC. It says PRTSCR, and what you do if you hit Control and that, it takes a picture of your whole screen. and then you save that picture and send it as an attachment.
And on some computers, it's the Windows button. So you hold down the Windows button and press the print screen button. It just depends on the computer. So if Control doesn't work for you, try that.
Thank you, because it's true. You know, I mean, this is one of the issues, of course, is that people could be watching this on multiple different kinds of computers. I mean, I don't know if you were working it on an Apple computer, it might be a whole different deal. And I don't use Apple computers, so I don't really know what it might take. So you could take a picture with your cell phone. You could take a print screen picture. You could, I'm going to go back when we're done today, or when I send you to work on the lab today for a little while. I'm going to go back and see if there's any way for me to modify this assignment so that it can be turned in by D2L. Because I actually thought there were people who had turned it in by D2L. I got some notifications of people who had. And so I apologize that I am not a D2L expert. And it seems like right now, and I understand why this is, I feel like the tech support people must be just overwhelmed with people who are trying to do virtual classes and have tech support. So in the interim, really, one of the best ways to send me things is to send me them by email, and that can be challenging. I'm not saying that couldn't be challenging to try and figure out how to do it. Of course, if you're going to send me pictures that you take with your phone or you take print screens, you don't need to send me anything that, like, you know, the beginning of this lab, all this stuff that's just content. Well, you don't need to send me any of that. You know, what you're going to send me is the stuff that you actually did and filled in. That's what you're going to send me. Everything I'm scrolling down right now, and I have yet to come to a single thing that you really need to send me. And I'm on page 6 of 14, right? So, you know, it isn't until we get down to, now I'm on, must be page 7, page 8, activity measure. See, now we're finally at a page 9, where you could do something, record the data, send a screenshot of this to me, and that would be great. I mean, that's complicated, but at least it will work now. And, you know, one of the things I want to say is, again, I'm constantly keeping in mind that we're sort of testing a lab that's never really been tested well before, and that makes me inclined to ask everybody to do the best work that they can, submit what they can, and I'm going to be very generous in assigning points. Okay. Okay.
Sounds good.
All right. That's the way I'm going to handle it, but I'm going to see if I can't somehow make this work for D2L. Now, one thing I did while we were doing, go ahead. While we were doing all of this, one thing that I did is I put, what did I do with those documents? Oh, I'll find them again. I put this document, the one on Alka-Seltzer science. Boy, I apologize. Oh. I uploaded the Alka-Seltzer science lab onto my Pima. As soon as we're done, I will upload it to D2L. But that was this. Oh gosh, I need to coalesce some of these documents. I apologize. I shouldn't have to spend this much time looking for a particular document, which I had up, and then I managed to lose it. Just be patient with me. I apologize. Of course, I guess I should have gone to my Pima. I should have gone, excuse me, to should have gone to my Pima, and the document has already been uploaded. Oh, okay. Steve, this is making me a little bit crazy. There it is. Alka-Seltzer Science at Home. So, this document is posted on my PIMA, and this document is, I'm going to make it available on D2L as soon as we finish today. But this document is a lab that we're going to do using Alka-Seltzer. So here's what all I would like you to do today, okay? I don't want you to go very far on this today. I want you to read through the top part, take a look at this equipment list. This is part of what you're going to do when we end in a little while, and you're going to go around your house and try and say, okay, do I basically have this equipment? And the equipment list says we need at least 2 intact Alka-Seltzer tablets. Usually they come 2 to a foil line pack. It would be better to have 3 for a specific reason. So if you could get, if you could get 2 packets and you have 3, that would be nice too. Because we could use a 3rd tablet to sort of think of this experiment. Okay, then I've got 2 identical clear containers. Now these could be glasses, plastic tubs. I mean, if we were in a classroom, we would have beakers, but we don't. So, but we want 2 identical clear containers so that you can see through them. That's all. These could be 2 identical glasses that come straight out of your cabinet. Now, stopwatch or timer, that could be the stopwatch on your phone. It could be a stopwatch you just happen to have on your watch. Then I don't think you're going to have any trouble finding some cold water and some hot water. Okay, and when I say hot water, I'm not asking you to boil water. Please do not boil water. It is unnecessary for the purpose of this experiment and potentially dangerous. And I know that sounds crazy, but I've actually been involved in an accident where boiling water got poured on somebody, and it was horrific. So notice, a measuring cup that, as I said, is calibrated in milliliters. Remember, lowercase m, capital L. Now, that measuring cup, I mean, most measuring cups, like, in my house, I don't know how many different measuring cups I have, but they are calibrated on one side in, ounces and cups, and the other side in milliliters, right? So you're going to look around your house, and as part of the lab, you're going to look around and see if you can find this equipment. And then here it says a centigrade thermometer would be great.
Back to school shirt. Yeah.
Could you find, and I'm asking, could you find one in your kitchen? Because I have, like cooking.
Oh, no, there's one in the house.
I've got cooking thermometers that have the option of reading in Fahrenheit or in centigrade. Some of them have a scale that is both in Fahrenheit and centigrade, and some have a button that you push and it has centigrade in it. But look, if you can't find this, it would be great if you could find a centigrade thermometer. If you, I guess, one scenario could be that you only have a Fahrenheit thermometer, and then you figure out how to make the conversion. And the conversion, even though I've said you don't need to do the conversion, their conversion is listed in the lab. It is not necessary to have a thermometer to do this experiment.
Oh, okay.
Okay, it is not necessary. It'd be great, but it's not necessary. Okay, so then here is our research question that is the very basic research question for this experiment. Okay, now here's what I want you to work on and think about today before we meet and talk about this again today. The only questions 1, 2, and 3, okay? Do not do any other questions, right? Don't go ahead and fill anything else in yet. You're just going to look at and think about and write answers to questions 1, 2, and 3. That's it. Okay, does everybody understand that?
Yes.
Because I don't want you to try and move beyond this and then go, well, Steve, I don't understand what you mean by this. Well, I don't think there's any question on this portion of the page that you couldn't think about and answer, even if your answer is no, right? So the research question that we're going to answer, and, you know, I'm going to tell you, I do this exact same research question in a classroom. This is actually kind of a classic research question that's used to teach the scientific method. I'm not kidding. So this question, will Alka-Seltzer dissolve more quickly in warm or cold water, is an experiment that we're going to actually do and work all the scientific parts of it. But the very first part, questions 1, 2, and 3, are the exact right place to start working on this lab. Now, I did say that most of the time, right, when you generate a research question, it's really a rough draft, because when you look at the research question that jumps out of your mind, the question could be, why won't my car start? Or are men taller than women? Or does drug A cure the common cold? Whenever you have questions like this, there's always issues with the precision and the clarity of the question. So when I look at this question, will Alka-Seltzer dissolve more quickly in warm or cold water, I immediately see things about it that make me think, I don't totally understand what that means. And that's where we are now. I want you to look at this question and go, I don't totally understand what this question means. And then answer questions 1, 2, and 3. Now, question number 3 does ask you to look at the equipment list and think about and design a very basic experiment to test this research question, okay? And I'm just asking you, say, okay, I'm looking at the equipment list, I'm looking at the question, what kind of little experiment could I do to get an answer to this question, right? Now, again, the only difference between this and my classroom would be we would have all this equipment laid out, but I would still insist people think about this and we would work through it. So that's your assignment for the rest of the class today, is to work on this research question and questions 1, 2, and 3. And that's it. Please don't, I don't care if you look at the rest of this, but don't even try and answer any of the other questions because might be totally wasting your time, okay? Now, again, this is already posted on my PIMA. You know, I'm going to drop this down for a minute and not lose it. I'm going to go over to my PIMA here, and I'm going to look and see where did it end up. It's right there. It's supposed to be document number 9. Okay, and I'm going to make it document number 9. I like numbered documents, and that's kind of one of the things that's bugging me about D2L. I have not figured out how to number documents in such a way that they appear numerically. Okay, so I'm fully admitting to you that I am learning about D2L on a day-by-day basis. All right, but do you notice this is now document number 9?
Yes.
That's where that document is, and it's a Word document, so you should be able to enable editing on it and then just fill in the very top part. And eventually, when we're done with it, we'll either drop it in a D2L Dropbox or you will email it to me, okay? One or the other. But it's available on my PIMA, again, in 5 minutes when I say that I'm done today and it's up to you to do the work on the lab, then you are going to work on that for a little while, okay? And when we meet again tomorrow, we'll discuss, we'll work on it, and we'll continue working on scientific method and all that, okay?
Sounds good.
So one thing I want to do is, and this always kind of makes me nervous, is I wanted to go. What makes me nervous is telling people about thought questions right before a quiz, okay? And then having the thought questions. Why didn't I just use? I was going to say what thought questions I had placed here were, well, O through W. Let's just look at O through W for a minute. O through W is all metric system stuff, right?
Mm-hmm.
And you know what? I don't think there's a single question in O through W that hasn't been answered 3 times, right? There you go. So I'm not worried about O through W. I'm going to go up to B through G, okay? And guess what? I need to pull G off, don't I? Because look at G. G says, what exactly is a hypothesis? Have I defined that? No. So I will not ask you about G. All right, does everybody understand that?
Isn't like a hypothesis, would it be valid to say it's like an educated guess?
Well, thanks for proposing that as an idea, okay? But I actually want to say that I'm going to give you a definition for a hypothesis that's much better than that one, okay?
Okay, cool.
I mean, honestly, here's the thing. I mean, believe me, I appreciate what you said. I just want to say that an educated guess has always been one of those ones that I just never really quite understood what it meant. I've read this a million times. I spent a lot of time reading about science. When someone says a hypothesis is an educated guess to me, I go, what do you mean? What is educated mean, number one? What does guess mean? What are you guessing about? So let me just rephrase it here, but I'm not going to include this on the quizzes. If you said to me, look, Steve, a hypothesis is an educated guess about a possible answer to the research question, then I would say that was a great definition, okay? But without that second part about what it is, then I really don't know what we're guessing about.
Okay.
When we do science, when we're doing the scientific method, we are, as part of that method, we will generate a list of possible answers to the research question. That's what a hypothesis is. It is a possible answer to the research question. It could be a great answer. It could be a horrible, awful answer. But it gets to be on the list because all it is a hypothesis, a possible answer. And whenever you do science, you generate a list of hypotheses. And you hope that on that list, there's good ones. And you hope and you expect that there's probably going to be some not so good ones, but that's totally normal. And I will show you exactly how to eliminate bad hypotheses off the list in 2 seconds. Right? I will show you how to eliminate most bad hypotheses. But to go back to it, don't worry about G right now. After tomorrow, then you'll have to worry about G. Okay? So for Thursday's quiz, you'll worry about G, but not for tomorrow. I got a little bit ahead of myself. Now, what is interesting is, what is true is that I did actually answer I, didn't I? What is the difference between a hypothesis and a theory? I did answer that. But I'm not going to worry about that right now. Right? We talked about the basic process of science. I said a theory is a well-tested hypothesis that has been tested and tested and tested, and it's never made a false prediction. Right? A theory is a higher level than a hypothesis. And we talked about that. But I'm not going to worry about that. What I really want to do here is I really want to go back to this, whoops, come here, PowerPoint. And I want to go back right here to this agenda, and I want to go B through F, right? So please make it, I don't post this daily agenda, So please make a note that you don't need to worry about G for this upcoming quiz, okay?
Okay.
All right, so everybody knows what they're going to do in the next few minutes, right? I mean, I'm going to stop talking and I'm going to go away so that you can actually do the work that you need to do. And that is the lab work. And so, like it says here in the chat, look it over, answer questions 1 to 3, but don't move beyond that, okay? Because when you move beyond it, you might be inclined to start writing stuff, and I just don't really want you to write stuff until I've had a chance to talk about how we generate hypotheses and predictions and things like that. Okay. So everybody knows what they're gonna do?
Yes.
Do we email it to our answer?
No, just hang on to it because we're gonna discuss it tomorrow. So you're not gonna email it to me until it's all filled in. You're gonna work on it. You're going to think about it. We're going to have a class discussion about it tomorrow to the best of our ability. We're going to think and work on it tomorrow, and then we will move on. Okay? All right, everybody. Thanks for coming to class today. I really appreciate it. I'm not going to forget, as soon as I'm done here, I'm going to post that lab on D2L. I'm going to try and tweak the other measuring lab on D2L. And again, when I say I'm going to post a quiz tomorrow morning, I'm probably going to post it pretty close to the beginning of class. And it will have 48 hours to work on it, an open note, open book, and then you will just send it back to me as an email attachment. Okay?
Sounds good.
All right, that's the plan. Stay safe, stay well. If you're out there looking for Alka-Seltzer, please be aware that we are an epicenter for the COVID-19 virus. And I've already lost 1 student to COVID-19 since last week. So please, yeah, be safe when you're out there. All right. I'm going to post this recording just in case anybody wants to watch it.